Okay, today's lesson we're going to talk about applying the side, side, side and the side, angle, side to construct triangles and solve problems. We're going to prove triangles congruent by using the side, side, side and the side, angle, side. In lesson 4-3, you prove triangles congruent by showing that all 6 pairs of corresponding parts were congruent. The property of triangle rigidity gives you a shortcut for proving 2 triangles congruent. It states that if the side lengths of a triangle are given, the triangle can only have one shape. Looking at your teaching transparency, our first theorem for today, or our first postulate, side, side, side congruency. What this is stating is if 3 sides of one triangle are congruent with 3 sides of a second triangle, then you can conclude that these triangles are congruent. For example, segment AB is congruent to FD. Segment AC is congruent to FE. And segment BC is congruent to DE because of the measurements. Now we're going to explain why these triangles are congruent by using your side, side, side. So when you're using side, side, side postulate, you've got to prove all 3 sides congruent. So let's look at segment AB. AB is congruent to this segment. When you write your congruency segment, make sure that you put your vertices in the correct order. AB is going to be congruent to DB, not BD. This is given. AC is congruent to this segment. AC is going to be congruent to DC. Again, that is given because of your markings. Therefore, the third side, BC, this segment right here, which is BC, these segments are congruent because of your reflexive property. Once you have all 3 sides congruent, you can write your congruency statement with the triangles. Triangle ABC is congruent to triangle DBC because of side, side, side. Okay, we're going to do this again. I'm going to be quiet. I'm going to work it on my own and let you try to work it on your own. I do want to say, students, on this congruency statement, be careful because you've got the same segment here, but you want to go back up here and look at your triangle congruency statement. I have vertices CA. So you can't put CA as congruent to CA because your vertices are different. Notice how A corresponds with C and C corresponds with A. An included angle is an angle formed by 2 adjacent sides of a polygon. Angle B is the included angle of segment AB and BC. So if we were to use this as our included angle, the side lengths you would need is AB and AC. Next, postulate side, angle, side. If two sides and the included angle of one triangle are congruent to two sides and the including angle of the other triangle, then the triangles are congruent. What we have here is segment AB congruent to segment EF. We have segment AC congruent to ED. We have angle BAC congruent to angle FED. This is the included angle because these two segments make up that angle. This is the included angle because these two segments make up that angle. Therefore, you can use side, angle, side. The angle must be included in those two sides. Okay, so now we're going to prove these triangles congruent by using side, angle, sides. We got to prove two sides congruent and one angle congruent. Okay, so let's start with what's given. We can say segment XZ is congruent to this segment right here, XZ, so that's going to be VZ. We can say WZ is congruent to this segment. So YZ congruent to WZ. Okay, I've got my two sides. Now I need the including angle of these two sides right here. So I'm looking at this angle and this angle. So angle XZY is congruent to angle. I have XZY, so when I list my second angle, XZY, VZW. Y, these are vertical angles. And you all know that vertical angles are congruent. I have my two sides, my including angles, so I can write my triangle congruency statement and say that triangle XYZ is congruent to triangle VWZ because of side, angle, side. Okay, let's try another one like that. Side, angle, side. Got to prove two sides, got to have that including angle. So I have segment AB congruent to segment DB. I have segment BC congruent to segment BC. And I have angle ABC congruent to angle DBC. Therefore, I can write my triangle congruency statement. Show that the triangles are congruent for the given value of the variable. Okay, we've got our congruency statement. And we've got three side measurements. So these triangles are congruent because of side, side, side. Okay. So let's see here. PQ equals x plus 2, well, we're going to substitute 5 in for x, so PQ equals 7. PQ, MN also equals 7. All right. RP equals 3x minus 9. 3 times 5 minus 9, which is 6. RP is the same as OM. OM is also equal to 6. And then our last side, QR equals X. Well, X equals 5. And QR is the same as NO. NO is also 5. So we just proved triangle MNO is congruent to triangle PQR because of side, side, side. Okay, same thing. I'm going to be quiet and let y'all do this one on your own. Only thing different here is we're going to use, because we've got two side measurements and we've got an angle, so we're going to try to use this. Okay, last one. We're going to write a proof here. We're going to prove these triangles are congruent. Okay, so we've got parallel lines. We've got one segment congruent that's given. So let's start with what's given. BC is parallel to AD. So what that tells me is angle ADB is congruent to angle CBD. Why? Alternate interior angles are congruent if you have parallel lines. Segment BC is congruent to segment AD, given. We know that segment BD is congruent to segment DB, BD, DB. Why? Reflexive property. So we can write our triangle congruency statement because of side, angle, side. That's it.